In this video I will show you how I port my demo app to the web. This app was made for my other video on showing you how you can integrate Expo SQLite in your project, do database migrations, and how you can integration test Expo SQLite on your local machine in Node.js. And yes, this app should work on web, SQLite should work on web. Thanks to WebAssembly, it brought us all these wonderful things, like running native code in the browser. One YouTube user asked me if I could extend my example with Redux, but then I thought, yes, Redux is a great solution for handling complex data, and I can definitely include this in this example demo app. But before making a Redux version, I'd like to make my app work in web first. I will use several solutions to make this work. I will use SQLite.js and local storage, and the last one is IndexedDB. Why not? So the first step would be to install the necessary dependencies. Let's shut this down. And the web. I already have a script for it. It's this script. And of course, it doesn't work because Expo SQLite was not adapted to the web. It works on Android and iOS, but not on the web. So there are a couple of solutions here. I have to make an adapter for the web. I'll show you an example using the local storage, IndexedDB, and lastly SQLite in the browser. So you can choose whatever you like. The issue why it doesn't work is all over the code. For instance, it's in the SQLite provider over here, which calls the package that doesn't work in web, and also my client that does the data fetching and inserting is called all over the place, at least in this detail page and in the index page. So I have a little bit of repetition. A quick and easy fix would be to make, sorry, not Android, but SQLite provider.web.tsx, and here I would make an adapter that just works on the web. And I should do the same in the task client. Again, make an adapter because I cannot use this package. I don't like this solution because I often find myself fixing this main module and then I forget that I have a suffix module, and why does it work with this platform? I just forget that I created another adapter module. So there's other way around this, not to use the module with prefixes, with platform prefixes, and I'll show you in this video. I first want to create several task clients depending on the storage it uses, because it's different logic for fetching and writing data. Let's move it here. And I will rename this to SQLite. And let's create another one that is called maybe local storage. And I want them to share the same interface. So I'll create types. And that interface will have these methods. and it will not have these implementations. And this will be the implementation that will be called on the web. So it's relational on the native, but it's no SQL exactly, no SQL on the web. And also notice that data needs to be serialized when writing. So I created the local storage test client and SQLite test client, but I need to somehow provide a different storage depending on the platform. And I first want to extract this SQLite provider from the layout. And I'll call it SQLite data provider. And I also don't like this name being hard-coded, so I will put the storage name in the app config. You can put anything in the extra. New recommended way is to put everything in the environment variables, but I don't like it. I will be using extra until it gets deprecated. Let's call it test. Where was I? I can read that config constants and it's called config extra, expo config extra. What was the name? DB name. Okay. Let's put the DB in a state. And instead of ready, I'll just return null. And of course, and let's call it over here. It still doesn't solve our issue, but this cleaner, since I don't call anything related to SQLite in the layout. And now I need to call the local storage data provider. It will be a dummy, but it will make sense in a minute. Now that we have two data providers, I will create a single one which calls them depending on the persistence type. Okay. And But to know which one to call, I will create a persistence type. And I like to put my types in a dedicated module. It looks a bit cleaner to me, especially if it's called all around the modules. Okay, suggestion is all right. And this accepts also a persistence type. Let's create a type definition of the properties. Correct. Now I need to call the local storage data provider and SQLite data provider in this component over here. And for that purpose, I'll create a higher order component. Okay. Let's leave it like this. Yeah, it accepts persistence type. And it returns nothing at the moment. But it will in a second. The component that it returns will be a component depending on the persistence type. We have a dummy component, but it will be something in a second. It will be if local storage, it will be local storage data provider component, otherwise SQLite data provider. Looks okay for now. And it will be wrapping the app data provider, that component, and receives a persistence type. Sorry, it will wrap the resistance provider wrapper, and it receives the persistence type. The problem with this component screaming is because I provided that it returns just a functional component that should accept something. Let's, instead of using this and in other data provider props with children, I'll define a type that is called data provider props. And instead of children, I'll accept not children, but a function that accepts the task client and returns the React node. Good thing that this is an interface, so we're clear now from the specific implementations. And here it should return the data provider props. And instead of children, this wrapper will accept the data provider props and the persistence type. But it's still incorrect because I need to adjust this, and I need to adjust the local storage data provider, but let's keep it at the SQLite data provider. I need to provide the task client, right? And it will be new SQLite task client, which accepts the DB. And the local storage will also accept, and children is again a function that accepts the task client. Okay, so this is done. And we're clear over here, but we're not clear in the app data provider. Because let's call this just props. And it returns children. We need to solve this issue because this will not work. If I call it in the layout, it will not work. Layout will not be an issue, but let's use just a second. Let's provide it different storage depending on the browser. So on web it's SQL, on web it's the local storage, and default native is SQLite. Sorry, I used an enum. Okay, so now we got rid of using the specific storage implementation in the layout, and we still need to solve this part. For that purpose, to solve this issue, I will create another context, and that context will provide me with the task client wherever I need to use it all over my application. We'll use the context API. We'll create another TypeScript file called data context, and that data context will return task client. Again, an interface, not an implementation. Wonderful. And okay, nice. And I can get rid of calling the SQLite in my pages, and it works. And one more place in index. What did I call? Cool. So everything in the app directory is rid of the specific implementations. But I did provide the data context, but I also need to provide it with the provider, because I'll get this error. And also there's an issue with this returning a function, and there should be children should be here. So let's keep the props, and we will return not children, but the data context provider. Okay. And I think I solved it. I think I solved it, and I can now run my application in the browser. Let's hope it works. Cool. I'll open the console over here. Let's see if it works. And what's in the local storage? It's saved in the local storage. Okay, so the plan was to port my up to the web and make it work on the web. I did this, but I also want to implement the other storage solutions. I will implement IndexedDB and also make it work so I can use the SQLite in the browser. And next, what I want to implement is IndexedDB. Instead of async storage, IndexedDB is asynchronous and it doesn't have such a limit as local storage has. It was 5 megabytes, so it's better suited for storing larger amounts of data, and it is also structured. And you also don't need to serialize JSON data. Since I implemented the storage data providers and specific clients, I just now need to implement the IndexedDB data provider and client task client specific for IndexedDB. IndexedDB data provider needs an IndexedDB client. And let's provide a dummy for now. Let's provide a dummy in the IndexedDB data provider. But similarly as in SQLite data provider, we need the database and we need to initialize the database. It doesn't have migrations like we did the ones in SQLite, but it does have something similar. You don't create a table, but you create your schemas. Something similar to MongoDB. It's not SQLite database, but in DB, it's in IDB database. And if it doesn't exist, don't return anything. And we need to provide the DB to the client. And the client to be more strictly typed. This is incorrect. We need the database and provide it a schema. And our task will be, it will not be, it's terrible autocomplete. It will be value, and our task had an ID. It had created that, and it had an updated that. And that is it. Let's extract the schema in types and call it the IndexedDB schema. And then our IndexedDB client has to accept the database. And it is this database. Okay, perfect. It still doesn't do anything, but it will in a minute. Okay, perfect. Let's go back to app data provider, and instead of this dummy, we will provide it with the actual provider. What's left? What's left is the initializing the database. And it is an async operation, so it will need to be initialized in the async function. Let's do a try catch. Try catch. And set db with await open db. I don't like this suggested hard-coded value. I will use the same one as I used over here. And what's this number? This is an indication of the database version. So if you were to change your schema, you have to bump the version. Let's put this also in the app config. db. Okay, and let's call this version over in the... I have too many open modules. Where was I? Config IndexedDB version. And this last argument is the argument that accepts, let's see what it accepts, several callbacks, but I want to implement the upgraded callback. And upgrade callback, this is not the correct autocomplete. If it doesn't contain tasks, because we defined the task, we will create a migration. And migration will be to tasks, and next time the task is saved, the ID will be bumped. This is it for implementation of the storage provider, but this is still left. It will not work, this is a dummy. And now I need to serialize it to my type. Otherwise I will just return tasks, but I cannot because I'm working with dates. And same thing for the updated at. Oh, sorry, this all needs to be asynchronous. Oh, I was implementing the wrong one. Okay, tasks, delete. This is simple. And add will be and okay, cool. This is it. What did I didn't implement the getter for detail. I need to implement serializing to my type, but let's create a helper function that is called serialize. No. To task. It is DB object. Any. Let's say it's not an any. It is IndexedDB schema, tasks, and value. Perfect. And it returns a task. And let's call this serializer over here. This looks cleaner now. Okay. And okay, now this is cleaner and I think we're done. To use IndexedDB instead of local storage, we will just put IndexedDB over here and check the web again. It doesn't work. Why? I messed up something. Let's see. DB version and Expo constants won't work in the web. Too bad, but this will not work. I need to use the environment variable. Let's keep it like this for now. And it's over here. I completely forgot that Expo constants won't work on the web and they are slowly being deprecated. Okay, now it should work. Okay, let's create a new task. And this task is now present over here. It's created in the tasks. It won't refresh by itself. You need to manually press refresh to see what's going on in the IndexedDB. Now to be using SQLite in the browser, I need to implement with SQL.js. I saw that's a solution for using SQLite in the browser. And I need to get rid of all of these calls to Expo SQLite. So one solution would be to reuse lots of methods, and this provider I can reuse it. And I can reuse the DB migration runner and also the SQLite task client. But I need to implement an interface that follows the SQLite database. So at least all of the methods that I'm using in the application. So one example, one solution would be not to call imports from Expo SQLite, but let's call imports from SQLite database. And instead of calling Expo SQLite, we will be calling the import from over here. It will make sense later. Let's see where Expo SQLite is called. It's called in a lot of places. This is all right. And okay, now we're done. Okay, now we're done. And here I can't escape using the platform specific module. So open database async is a function that returns an SQLite database. And that is exactly what we will return. It will not come from the SQLite. Let's call it any for now. This is wrong. Do I call open database async with any arguments just to check? Okay, perfect. So I don't care what are the options. And if I go back to that example, how to initialize the database, it will be like this. And now I need to implement all of these functions that were also functions on the SQLite database. So it was a similar solution if you watch my other video when I was mocking the Expo SQLite. I needed to provide some other implementation, but following the same interface, right? So I believe I need to implement all of this. Will not prepare async. This was, I'm not using it in the code. One user asked me if I could provide an example. Let's see what happens. Okay, this is all right. And this is not the same implementation. I don't need the wait because SQL.js uses blocking. Yeah, it doesn't have another example. Okay. Here I need to put the bind params. And what else? Let's call this. Let's run the painful part is that all of these libraries are different. And I need to manually type so it follows at least the same interface. Get rows modified. No. Select. I believe this is correct. For now we have all of these. And then in an ideal situation, it should run. So let's go back to layout and select SQLite for web. I want to check if it works on the web. If I try running the web app again, it should run with this SQLite. And now it works with SQLite. But problem with this, it isn't very practical because it uses a virtual database that is stored in memory and that doesn't persist changes. So with every refresh, I would be executing the same migrations again and again. How you can solve it is maybe import an existing SQLite database or export the SQLite database. I would not use this for my applications, but I wanted to show it as an option for this example, if you ever needed to use SQLite in the browser. I'd either go with IndexedDB or async storage, probably IndexedDB if I had a larger database. This is not all. I want to create a button group that allows you to switch between different types of storages. So I want to extract the persistence type in a state and this is the persistence type. I need to create my button group. It's titled, I don't know, and two more buttons. And also I want to inline them. I want to type which type of persistence is being used. It works as expected, except this needs a little bit of styling. But that's it. I finished what I promised you in the start of the video. I ported my app to the web. I showed you 3 different types of storages that you can use for the web. For large data, I'd probably go with IndexedDB, or I'd use local storage. That SQLite and SQL.js, this was my first time playing with it. Would I use it? I don't know. There's no point if I can't persist it on the browser refresh. Anyway, everything is, all of the code is available at my GitHub repository. You can also read my article. In one of the next videos, I will extend my application more and include Redux. Thanks for watching.